So the topic we're going to learn about now is called powers. Okay, so a power is an expression that is made up of a base and an exponent. Now for the base, I always like to remember that as the big number written on the bottom. So the power would be the number on the bottom, okay? And that's going to be the number that multiplies by itself. The exponent tells you how many times that base is multiplying by itself, and it's that little number up top. And the whole thing all together is called a power. Okay, so a power is made up of a base and an exponent. Okay, so I want to be very careful with how we say some of these things. Okay, so I might say 5 to an exponent of 3, right? I don't say 5 to the power of 3, that's bad. We want to say 5 to an exponent of 3. Okay, because the whole thing is called a power. So if I catch myself, it's because I had bad habits in school, and we'll try and make sure that we have good habits going forward. Okay? So when we're talking about exponential form, so here I've got that same power we had before, 5 with an exponent of 3. Okay, and what that really means is this base of 5 is going to be multiplying itself, and it's going to repeat itself 3 times. Okay, so when I write it out, it would be the same thing as 5 times 5 times 5. So there are 3 5s that are multiplying themselves. Okay, if I look at this other repeated multiplication down here, I've got 7 times 7 times 7 times 7 times 7. So the number that is being multiplied by itself over and over is 7. And there are 5 of those 7s. So in its exponential form, or written as a power, we would say 7 with an exponent of 5. Okay? All right, so if we're going to look we're going to look at going back and forth between exponential form, repeated multiplication, as well as standard form. Okay, so if I have 6 to an exponent of 3, that would be the same thing as 6 times 6 times 6. And if you type that out into your calculator, that would give you 216. Okay, if I have something like 3 exponent 4, that's 3 times 3 times 3 times 3. And if you type that into your calculator, 3 times 3 times 3 times 3, you'd get 81. Okay. Now if I have 4 times 4, we've seen this before, okay, when we were working with perfect squares. So 4 times 4 is a nice perfect square. We would say that's 4 squared. Okay, 4 with an exponent of 2. And 4 times 4 we know is 16. Okay. I'm going to look at this one now. 2 exponent 4, so that would be 2 times 2 times 2 times 2. Okay, and 2 times 2 times 2 times 2 is also 16. So when I did this in class, someone noted, hey, wait, when I switched the base and the power, when I switched the base and the exponent, I ended up getting the same standard form. Okay, this is actually one of very, very few cases where that works. Let's take a look at this one here. What if I switch the base and the exponent, and I switch 3 exponent 4 and write it as 4 exponent 3? Will they be the same thing? Well, this would become 4 times 4 times 4, and that's 64, which is not the same thing as 81. So just because we swap the base and the exponent does not necessarily mean they will be equal. In fact, it's more likely that they will not be equal to one another. Okay? All right. So, what about negatives? Okay, so I've got negative 2 with an exponent of 4, where the negative 2 is in brackets and the exponent is outside, as well as negative 2 with an exponent of 4, where I don't have any brackets anywhere. Okay, so I want to remind you of BEDMAS. Okay, so we've always talked about BEDMAS, and for the longest time we've said brackets, exponents, divide, multiply, add, subtract, but we've said don't worry about the exponents. Well, now we have to worry about the exponents. Okay, so with this negative 2 with an exponent of 4, when it's in the brackets, I like to draw for myself the 4 in the exponent is touching the bracket. Whatever the exponent is touching is what is repeated. So since the exponent is touching the bracket, the negative 2 in brackets happens first, and then everything inside that set of brackets is repeated. So this one, the brackets would repeat as well. So everything that that exponent touched repeats. And since the exponent was touching the brackets, it's everything in the brackets is repeated. So this then is 4 negatives, which we know will be a positive. And then 2 times 2 times 2 times 2 is 16. So we get positive 16. Over on the right-hand side, this exponent of 4 is touching the 2. And so the 2 is repeated 4 times because the exponent is directly touching that 2, but the negative is not included in the repeated multiplication because the 4 doesn't act on the negative. It's just acting on the 2. So this one will become negative 16. Okay, now we saw when the brackets are repeating, okay, so here's what this one would look like. Another way of writing negative 2 is negative 1 times 2. Okay, now if I have my exponent touching the bracket, everything in the brackets happens 4 times. So I still have those 4 negatives. But when I'm looking at my other one, if I write it as negative 1 times 2, and then I still have that exponent of 4, now the exponent of 4 is directly touching the 2 only, and so that negative 1 hangs out in front while the 2's multiply each other. Okay? So the negative in the brackets means that it's repeated and it is part of the base. If the negative is sitting out front, then it's just part of what we would call the coefficient. Okay? So if the negative is in brackets and the exponent is outside the brackets, then the negative is part of the base. If the negative is not in brackets, or the exponent directly touches the number, then the negative is not part of the base, and it is just considered a coefficient. Okay, so we need to be really careful with where that negative sign is. If it's inside the brackets, okay, and the exponent is outside the brackets, the negative is part of the base. All right, but if the negative is not in brackets, or if it is in brackets, but that exponent then is touching the number directly, not touching the set of brackets, okay, then it is just a coefficient, not part of the base. All right, so I'm going to look at a couple strange examples because you're going to see some of these on your sheet this week. Okay, so again, I'm going to use this same idea. This exponent of 3 is touching the bracket. Okay, so I need to take everything inside the brackets and multiply it all together. So that gives me 2/3 times 2/3 times 2/3. I'm just multiplying fractions now. I would look for any cross reducing, which I don't have between 2 and 3. Okay, so that's going to give me 2 times 2 times 2, which is 8, and 3 times 3 times 3, which is 27. Okay. For the second example, when I look at that exponent of 3, this exponent of 3 is directly touching the 2. It is not touching the denominator of that fraction. It's only touching the numerator. So this one, the numerator is repeated 3 times, but since that denominator, the exponent wasn't touching it, the denominator has to stay as a 3. So this would become 8/3. Okay, so it's all about what the exponent is touching directly. When it touches that set of brackets, everything in the brackets gets repeated. Otherwise, it's just the number it is touching only. Okay, now for something like a decimal, if I've got 0.2 to an exponent of 4, that would be 0.2 times 0.2 times 0.2 times 0.2. And it was in the brackets, so I included the brackets. Okay. Now the problem with doing that is I now need the calculator to do that calculation for me. So, like I always try to do, I don't want to work with decimals because decimals are generally more difficult than fractions. So what I'm going to do is instead of writing 0.2, I'm going to write that as 2/10, right? If I said that decimal properly, instead of saying 0.2, the decimal is 2/10. And 2/10 can be reduced to 1/5. And 1/5 to an exponent of 4, well now that exponent of 4 is touching the brackets, so everything in the brackets is repeated, and that's 1/5 times 1/5 times 1/5, and 1 times 1 times 1 times 1 is 1, and 5 times 5 times 5 times 5 I think I said 4 of them, is 625. Okay, so I'm able to do that calculation much more simply than I'm able to go 0.2 times 0.2 times 0.2 times 0.2. Okay, so I like working with fractions instead of decimals if at all possible, especially with exponents. Makes it much simpler. Okay, so we'll go more in depth with some of these things later, but for now, that's the basics. Okay, so really, a power made up of a base and an exponent, and all we're looking at is the base is the number that is being repeated in the multiplication, and the exponent tells you how many times that number is multiplying by itself. Okay, so if you think back to the zombie video, how we said 1 day 2 zombies, and then 2 days there were 4 zombies, and then on 3 days there were 8 zombies, and what happened was another way of getting from here, from 2 to 4, was we said it was doubling, right? So we started with 2 and then we times by 2 to get to the 4. And then when we went from the 4 to the 8, we had to times by 2 again. So 4 was 2 times 2, but then we had to times by 2 again, right? And then on the 4th day, it's 16, and how did we get that? Well, we took the 8 from before, which was 2 times 2 times 2, and we doubled it and times by 2 again. So if you think back to my zombie example, another thing I could have done is I could have in another column said 2 exponent 1, 2 exponent 2, 2 exponent 3, 2 exponent 4, 2 exponent 5, and I can keep going. Right? So on the 10th day, when there was 1,024 zombies that took over Colonel McLeod, that would be 2 with an exponent of 10. Okay, and so that was how I knew we were working with exponential growth, because we were continually doubling the number of zombies. We kept multiplying the number of zombies by 2. We were repeating our multiplication by 2 over and over and over. So what I really showed you was the repeated multiplication, and I had it in standard form. But if you go back to that chart, you could write it out where the standard form changes into its repeated multiplication, and then you could put it into its exponential form after. All right, so that is your basic rundown on powers and exponents. Okay, next up is going to be our exponent laws, where we're going to find some ways of working with some large exponents and simplifying things without having to do a lot of calculator work.